Hello everyone, welcome to Ocean Cafe. Now in this lesson, we are going to apply what we have learned about arc length and sector. So this question is taken from GCE O Specimen Paper, question 21. And this concept has been tested quite often. Now, so let's solve. So in this case, all right, we want to change a sector and to make it into a cone. So basically, what we see here is we are using 2 points, say A and B, and we are going to join these 2 points together and fold the sector and to make it into a cone. So which means point A and point B should meet like this. So what must we know from here? So what do you know? So once we have this, right, you will observe that this arc length, all right, from the sector, it is actually the circumference of the cone. Yeah, and then the radius of the sector, it is actually the slant height of the cone. So this is something whereby you must be able to visualize. Now, so over here, what we see is, right, we have the radius of the sector. I'm using a capital R, right, to represent this radius of sector because small letter R has been used already, so I avoid using the same letter. So I have capital R. So since I know that the arc length of the sector is the same as the circumference of the cone, so what I'm going to do is I'm going to apply the formula arc length. Since this question is in radian mode, right? So I use the formula r theta, and then for circumference, right? We know that circumference of circle is equal to 2 pi r, and since they are equal, I'm going to put the two together, and with this I solve the equations. All right, I should be able to get 9.02. Yeah, so by using the calculator value pi, I will be able to get the value of r of the base circle easily, which is 2.87. Right, so in this case, I will leave the answer in 3SF. So this part here is quite easily done. Now, so let's take a look at the extension of what we have learned earlier on, even though this is not tested in the specimen paper, but I think it is good to know. So basically, same approach. So we have a sector, all right, and to fold into a cone. But in this case, instead of finding the base radius, all right, I want to find the surface area of a cone. So what you would need to know is the curved surface area of the cone here, it is actually the area of the sector. Yeah, so with this, do bear in mind, if the question asks you to find the surface area, right, you will need to take note that in this case, the base here, it is actually open. All right, it is not a closed cone. All right, it is an open cone. So therefore, you will not need to add the base area of the circle. Yeah, so we are only talking about the curved surface of the cone, so which is actually the area of the sector. So knowing this, I'm able to apply the formula. So surface area of the cone equals to area of the sector. So which means I know that area of the sector is actually half r square theta. Yeah, so this r is the radius of the sector. So putting all these together, I'm able to sub in the value, yeah, and I will be able to find the surface area of the cone easily, which is equals to 74.0 cm squared. So this would be an extension of knowledge that it is good to know. All right, so hopefully this will give you an idea, all right, what happened when a sector, right, became a cone. What are some things that you need to know? So I hope you find this knowledge useful. All right, so I see you in the next video. Bye.